Hi, and welcome to 3.2, Proof and Perpendicular Lines. So in 3.2, we want to focus on different ways we can prove things. So far, we talked about a two-column proof. Um, as you see in this quick example, we're going to prove the vertical angle theorem three ways with basically three formats. The proof is going to be the same, three different formats. The first one is that two-column proof. So here I'm going to prove the vertical angle theorem. I want to show that angle 5 and 7, those are my vertical angles, are congruent. Okay, that's what I'm going to try to prove. I'm given 5 and 6 are a linear pair, and 6 and 7 are a linear pair. Now, to do this proof, basically we take our givens, and then we say, well, if they're a linear pair, we know by the linear pair postulate that angle 5 and angle 6 are supplementary. Okay, angle 6 and angle 7 are supplementary. Now, when we have 5 or 6 is a supplement to 5 and 6 is a supplement to 7. 6 is a supplement to 5 and 7. Therefore, 5 and 7 have to be congruent by the congruent supplement theorem. Now, we could have also done this with a paragraph proof, and it's basically what I just said in the last one, how I read it. Sometimes you give your statement first and then give the reason, and sometimes you say, here's a reason, and this is what we can conclude. But basically, it's just how you would say it. If you're making a paragraph proof, you'd want to probably first do it in a two-column proof and then rewrite it. The longer the proof, the more likely it is going to be written in a paragraph proof. The third method is kind of, I think, the best method for learning about proofs. It's probably even better than the two-column proof. What we're going to do is do a flow proof. We're going to use arrows to show the flow of logic. Okay, so we start with just this first given. Okay, angle 6 and angle 7 are a linear pair. From here, the idea is I use an arrow to show that if angle 6 and 7 are a linear pair, then they are supplementary. Okay, so this over here we're not using at all. Once we conclude they're supplementary, we're going to take this idea that angle 5 and angle 6 are a linear pair, which means, and that was a given, which means angle 5 and angle 6 are supplementary. These were both the linear pair postulate. So this statement makes this statement makes that statement. Then we have to use both of these statements to come up with our conclusion down here that angle 5 and angle 7 are congruent to each other, and the reason is congruent supplements. So I like this because it shows what you need to make the statement. Okay, where if you look back at that two-column proof, the flow is just not there. This flows, it shows where it's going. We have three theorems for this section. First theorem is 3.1, if two lines intersect to form a linear pair. Linear pair are two adjacent angles that are supplementary. Linear pair of congruent angles. So if these are congruent, what do we know? Well, if they're congruent, they have the same measure. They have to be right angles or they're perpendicular. Theorem 3.2, if two sides of two adjacent acute angles are perpendicular. So two adjacent, so they share this side. Acute means they're small, are perpendicular. So this angle and this angle form a right angle. That's the definition of perpendicular. They form a right angle. Then the angles are complementary. Well, if that's a right angle, it makes sense that they would add up to 90. Kind of a common sense theorem, but we could prove it. And if two lines are perpendicular, so these lines are perpendicular, they form a right angle, then they intersect to form four right angles. So now, when we talk about two lines being perpendicular, not only do they, perpendicular means one right angle, but if we have two lines, it's going to form four right angles. All those angles are right angles. Uh, we'll do one proof here. We can probably prove it however we want. I think I'd like to try to do it in a flow proof. We'll see how that goes. Um, Now, I have the advantage of being able to move stuff around, but I'll try to get it right on my first try, but no promises. BA is perpendicular to BC. The nice thing about a flow proof is don't be afraid to write big and have your work scattered. If I was going to do a flow proof, it might take up a whole sheet of paper. And that's my given. So I write that outside of the box. And from that statement, what can I conclude? Okay, so I would conclude that angle ABC, so I'm using the picture, that angle, if they're perpendicular, angle ABC is a right angle. And what says that? That would be the definition of perpendicular. Now, from here, I can conclude that the measure of angle ABC equals 90 degrees. So I know I make this look really easy, but I know my definitions, I know my theorems, and if I know something's perpendicular, what do I know about that? Well, it's a right angle. If I know it's a right angle, what do I know about that? Well, it measures 90 degrees. And now I get to the measures 90 degrees, I'm asking myself, how does that help me get to complementary? So I'm going to start a new idea over here and say, I know the measure of angle 1 plus the measure of angle 2 has to equal the measure of angle ABC. I want to relate angle 1 and angle 2 to this 90 degree angle. Why is angle 1, this angle, plus this angle equal the big angle? What says I can add two angles? That would be the angle addition postulate. So notice there's no arrow to this. This is the start of a new thought process. Okay, so that's the angle addition postulate. And then from here, I want to relate these angles to angle ABC, or the 90 degrees. So I'm going to say the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So how'd that come about? I'm not going to go to too much. That would be, I took this statement here, and I'm substituting it in. So you don't really need to draw that arrow, but I'm substituting it in here. Okay, making that substitution. So I'm going to undo that. Wouldn't technically be in the proof. I'm going to drop two arrows like this to make this. Oh, actually, here's my mistake. I knew I'd make one. Here's the flow, right? I'm using this statement and this statement. I should really be drawing that arrow there. So I'm using these two statements to make a substitution. Okay? Don't think it comes easy every single time, even for a teacher, these things. It takes thought. And then from there, if I know that two angles add up to 90 degrees, I can make my conclusion what I'm trying to prove. Angle 1 and angle 2 are complementary. Angle 1 and angle 2 are complementary, and that is definition of complementary angles. Okay. So I'll try it again. Excuse me. So the given, and you can follow the flow. These two things, this and this, were used to make that statement, and then we made the conclusion. So these flow proofs are pretty nice. I'll let you look at that more if you need to. Ask questions tomorrow in class. Um, there's your homework, 2.2, 1 through 22. Have a good night, or if this is early morning, have a good morning. Talk to you in class. Bye.